All right, my friends, for part A, I've gone ahead and graphed vector u. Let's fix the notation if we're handwriting it. Make sure vector u has a hat. So there's the graph of vector u. If somebody said, quick, guess its magnitude, I would just pick a number a little bigger than 7. So I'd be like, oh, 7.2. Anyway, so I could see that vector u is, a little longer than 7 units. So hopefully that part makes sense. Now, if you're asked to find, though, the magnitude of vector u, then you would, go ahead and calculate it. So you could use the formula, the distance formula, where the endpoint is at 2, 7, and then the tail is at 0, 0. So you could kind of be really obedient here, and you could go 7 minus 0 squared plus 2 minus 0 squared, which, is really just what you would have gotten had you thought about the Pythagorean theorem. So 7 squared is 49, 2 squared is 4. So the magnitude of vector u is equal to the square root of 53. There we go. Okay. And if somebody said, quick, approximate the square root of 53. Well, I know square root of 49 is 7, and then this is just a little bigger than that. So I'd probably guess about 7.2 again. Anyway, now for part C, it says find the component form of a unit vector that has the same direction as vector u. So we're going to take vector u and we're just going to scale it down. So if it is square root 53 units long, we'd need to multiply it by 1 over its own magnitude to get it down to 1 unit long. I hope that makes sense. So I'd basically take 1 over square root 53 and I'd multiply it by the vector 2, 7. And then scalar multiplication, you just distribute it in. And when I'm at it, I'm going to go ahead and rationalize the denominator. So I'd write it as 2 times the square root of 53 over 53. And 7 times the square root of 53 over 53. There we go. That's that, my friends. Okay. And hopefully you're feeling good about finding, a unit vector that's in the same direction as a given vector, even if the magnitude is something that's irrational, like in this problem. Okay, let's move on. Let's talk about some special unit vectors, and then we'll have one last example that should be pretty easy for you. So there are two, well, if you're talking about 2 dimensions like we are today anyway, there are 2 special unit vectors. Okay, and we can draw you a cute little picture of them and everything. So draw a little XY plane. So each of these is just 1 unit. So one special unit vector and starts at the origin and then just goes along the x-axis for 1 unit. That is called I hat, and the special unit vectors you can see get special hats. And so I hat, I hope it makes sense, would have component form 1, 0. And then this other special unit vector starts at the origin also and just goes for 1 unit in the positive y direction. And that, my friends, is the special unit vector j hat, and it has component form, 0, 1. There you go. And, if you were in a 3D system, then you'd have 3 special unit vectors. Wouldn't that be fun? Anyway, but we're not right now. We're just in 2. So take a moment and commit I hat and j hat to memory. Notice the special hats. I'll be looking for you to use that notation correctly. And then think about example 5. So also as you go, you'll need to fix the notation. This is what it looks like if it's typeset. If you're handwriting, you would say graph vector v, which is defined as -2 times I hat times j hat. Graph vector u, which is defined as with component form 3, 2 on the same plane, and then write vector u in terms of the standard unit vectors. All right. Oh, and I apologize. I should have not said 2 special unit vectors. I should have said these are the standard, standard unit vectors. That would have been more appropriate. There we go. All right, my friends, last example. See how it goes. Check in with me in the next video.